You're staring at a perfectly good car amplifier sitting in your garage, pulled from your old vehicle or bought cheap on Facebook Marketplace, and a thought crosses your mind. This thing pushes 1,000 watts for under 200 bucks. Your home speakers need power. Why not just hook it up and save the cost of buying an expensive home amplifier? Seems logical, right? But here's what nobody tells you until after you've already bought the power supply, stripped the wires, and realized your setup sounds worse than your phone speaker. Car amps can absolutely power home speakers, but there's a minefield of hidden issues that forums and YouTube videos conveniently skip over. I'm talking power conversion nightmares, impedance mismatches that cook your equipment, safety risks that could void your home insurance, and sound quality that makes you wonder why you bothered. Stick around because I'm going to walk you through everything they don't mention. The real costs, the actual risks, and whether this DIY experiment is genius or just an expensive mistake waiting to happen. And before we get into the technical stuff, hit that subscribe button and smash the like. Drop a comment right now telling me what audio setup you're running at home and what's frustrating you about it. Are you dealing with underpowered speakers? Blown tweeters? Let me know. The power supply problem nobody explains. Here's the first massive issue. Car amplifiers are designed to run on 12 to 14.4 volts of direct current, the same power your car battery provides. Your home wall outlet in the United States delivers 120 volts of alternating current. In Europe, it's 230 volts. These are fundamentally different power systems, and you can't just plug a car amp into your wall. You need a power supply that converts that AC voltage down to 12 volts DC and, this is the critical part, delivers enough current to actually run the amplifier without choking. Most people grab whatever random power supply they find online, plug it in, and wonder why their amp keeps shutting off or sounds distorted at anything above whisper volume. The issue is amperage. A serious car amplifier pulling 500 to 1,000 watts needs 50 to 100 amps of current at 12 volts. That's a huge amount of power. Your typical laptop charger or lead strip power supply puts out maybe 5 amps. Plug that into a car amp and you'll either blow the power supply immediately or the amp will starve for current, causing voltage sag that leads to clipping and distortion even at moderate volumes. The practical solution most people use is repurposing a computer power supply, specifically an ATX power supply from a desktop PC. These are designed to deliver high amperage on the 12-volt rails, and you can find decent 400 to 600 watt units on Amazon or Parts Express for $20 to $50. Brands like Corsair, Evga, and Thermaltake make reliable units. But even here, there are traps. Not all computer power supplies are created equal. Some split their 12-volt output across multiple rails, each capped at 20 amps. If your car amp tries to pull 80 amps, it'll trip the protection circuit and shut down. You need a power supply with a single 12-volt rail or combined rails that can handle your amp's full current draw. Check the label on the power supply. It should list the amperage for each voltage. Add up the 12-volt amps and make sure it exceeds what your amplifier needs. Also, cheap power supplies, especially the no-name ones bundled with budget PC cases, are notorious for overheating or failing under sustained load. They're designed for computers that idle most of the time, not amplifiers pushing continuous power. Spend the extra 20 bucks on a quality unit, or you'll be troubleshooting failures constantly. Wiring the power supply requires some basic electrical knowledge. The ATX connector has a green wire called PS_ON that needs to be jumped to any black ground wire to trick the power supply into thinking it's connected to a motherboard. Without this, the supply won't turn on. Use a paper clip or a spare piece of wire to bridge these two. The yellow wires are your 12-volt positive output. Twist several yellow wires together to increase current capacity and connect them to your amplifier's power input. The black wires are ground. Again, twist multiple black wires together and connect them to the amp's ground terminal. Make sure these connections are solid. Loose connections create resistance, which generates heat and voltage drop, both of which kill performance. Some people solder and heat shrink these connections for reliability. At minimum, use quality crimp connectors. And this is important. Make sure the power supply's ground and the amplifier's ground are tied together properly. Ground loops, where you have multiple ground paths, introduce noise and hum into your audio. If you start hearing a low frequency buzz through your speakers, ground loop is the first thing to check. Impedance matching and speaker safety. Now let's talk about something that fries equipment and confuses everyone. Speaker impedance. Car amplifiers are designed to drive low impedance loads, typically 2 to 4 ohms. This is because car speakers and subwoofers are built with low impedance voice coils to extract maximum power from the limited voltage of a car's electrical system. Home speakers, on the other hand, are usually 6 to 8 ohms. This is a fundamental mismatch. When you connect 8 ohm home speakers to a car amplifier expecting 4 ohms, the amp has to work harder and less efficiently. It runs hotter because it's not operating in its optimal range. Over time, this can lead to thermal shutdown or even permanent damage to the amplifier's output stage. The amp is designed to dissipate heat based on expected 4 ohm loads. Push it with higher impedance, and it generates more heat than the cooling system can handle. The flip side is even worse. Some people try to increase power by wiring multiple speakers in parallel. If you connect 2 pairs of 8 ohm speakers in parallel, you drop the total impedance to 2 ohms. Connect another pair and you're at 1.3 ohms. Most car amplifiers will either go into protection mode and shut down, or if they don't have adequate protection, overheat and die. The amplifier's output transistors have a current limit. Too low an impedance means too much current, and those transistors cook. Even if the amp claims to be stable at 2 ohms, running it there continuously at high volume is asking for trouble. Car amps are tested at 2 ohms in burst conditions, not sustained home theater use. Wiring speakers in series is the safer approach for impedance management, but it cuts your power output significantly. 2 8-ohm speakers in series give you 16 ohms total, which might drop your power output to a quarter of what the amp is rated for at 4 ohms. You're left with an underpowered system that can't deliver the dynamics you bought the car amp for in the first place. There's no easy win here. You either risk the amp with low impedance, accept weak output with high impedance, or match impedance perfectly by using 4 ohm home speakers, which are less common and often more expensive. This is one of those details nobody mentions when they're posting their easy car amp home setup videos. Audio source connections and signal challenges. Getting audio into your car amplifier from home sources is another minefield. Car amps have RKA inputs expecting a line level signal, usually around 2 volts. Home receivers, computers, and phones can provide this through their ARCA outputs or headphone jacks using a 3.5mm to ARCA adapter cable. Simple enough, right? But here's where gain structure becomes critical. Car amplifiers have input gain controls, often labeled misleadingly as volume. This isn't volume, it's sensitivity adjustment. Set the gain too high and you'll clip the input stage, creating harsh distortion even at low listening levels. Set it too low and you won't have enough output. The proper way to set gain is to play a dynamic track at the loudest volume you'll use from your source, then slowly increase the amp's gain until you hear distortion, then back it off slightly. This ensures you're using the full dynamic range without clipping. Most people just crank the gain knob and wonder why their system sounds terrible. Then there's the remote turn-on wire issue. Car amplifiers have a blue or blue with white stripe wire that turns the amp on when it receives 12 volts, normally from your car's head unit when you turn on the stereo. At home, you don't have this signal. You need to wire this remote input directly to 12 volts from your power supply for the amp to stay on. This means the amp is drawing standby current continuously, usually half an amp to 2 amps depending on the model. Over a month, that's real electricity cost. Some people install a switch in this line to manually turn the amp on and off, but then you're adding complexity. Leave it on constantly, and you're burning $5 to $15 a month in standby power depending on your electricity rates. Not huge, but it adds up over a year. Ground loops are the other major signal issue. In a car, the chassis is the common ground for everything. At home, you have multiple devices with different ground references, your computer, your TV, your amplifier, and these can create ground loops where current flows through the audio cables, inducing hum and noise. The classic symptom is a low-frequency buzz that changes pitch when you move your mouse or increases when your refrigerator kicks on. The fix is either a ground loop isolator, a cheap $10 to $30 device from Crutchfield or Amazon that breaks the ground connection between devices, or running a dedicated ground rod for your audio system, which is overkill for most people. Isolators work, but they can slightly degrade sound quality. It's another compromise nobody warns you about. Safety risks and legal headaches. Let's talk about the scary stuff. Car amplifiers generate serious heat. In a car, they're mounted in trunks or under seats with some airflow and away from flammable materials. At home, people often stick them on shelves, in cabinets, or under furniture where ventilation is poor. Class D amplifiers, which are the most common type in modern car audio, run cooler than older Class AB designs, but they still get hot under load. Inadequate cooling can cause the amp to overheat, potentially melting wire insulation, or, in extreme cases, starting a fire. This isn't theoretical. There are documented cases of improperly ventilated car amps causing fires in home setups. In the United States, this becomes a problem with insurance. If your home insurance company investigates a fire and finds you were running non-O-listed equipment in a non-standard configuration, they can deny your claim. Car amplifiers are not O-listed for home use. They're designed for automotive environments. Same issue in Europe with set compliance and RoHS directives. Using automotive electronics in residential settings can void your coverage. The DC wiring itself is a hazard. You're running 4 to 8 gauge wire carrying potentially 100 amps of current. That wire needs to be fused close to the power supply, ideally within 18 inches to protect against shorts. If that wire chafes against a metal edge and shorts to ground, you've got a welding arc that can ignite surrounding materials instantly. Use proper automotive fuse holders with 60 to 100 amp fuses rated for your amp's draw. Use oxygen-free copper wire, not cheap copper-clad aluminum that has higher resistance. Route the wire safely, away from foot traffic and sharp edges. This sounds like overkill until you see what happens when 100 amps dumps through an unprotected wire. It's not pretty. If you're renting, there's another problem. Modifying electrical systems or installing non-standard equipment can violate your lease. Landlords can charge you for damages or even evict you for fire code violations. Own your home and you're still liable for building code compliance. Most jurisdictions require electrical work to meet code, and jury-rigging a car amplifier setup definitely doesn't meet code. You probably won't get inspected unless something goes wrong, but if it does, you're on the hook financially and legally. Run the wiring near Ethernet cables or power lines, and you'll introduce ORFI, radio frequency interference, that can disrupt your network or other electronics. Keep high current DC wiring separated from low voltage signal cables by at least a few inches. Sound quality reality check. Here's the thing nobody wants to admit. Car amplifiers sound different than home amplifiers, and usually not in a good way. Car amps are optimized for loud, punchy bass in noisy environments. They prioritize raw power and efficiency over sonic refinement. Total harmonic distortion specs on car amps typically range from 0.1 to 1%, which sounds low until you compare it to home integrated amplifiers from Yamaha, Denon, or Marantz that spec at 0.01% or lower. That difference is audible. Car amps tend to sound harsher, less detailed, especially in the mid-range and treble. They don't have the clean, transparent character of quality home electronics. Car amps also lack features that home users expect. No balanced inputs, which reduces noise rejection. No tone controls or room correction. No remote control, unless you wire up some kind of external volume controller. The gain knobs on the amp become your volume control, which means you're adjusting a trim pot designed for set and forget installation, not daily use. These pots wear out, introduce scratchy noise, and eventually fail. Home amplifiers have motorized volume controls or digital attenuation designed for thousands of adjustment cycles. Big difference in longevity and usability. The efficiency advantage of Class D car amps is real. They can deliver 1,000 watts while barely getting warm, which is impressive. But that efficiency comes with switching noise and artifacts that audiophiles complain about. Class AB home amps run hotter, but often sound smoother and more natural. It's a trade-off. If you're running a subwoofer for movies and you just want chest-thumping bass, a car amp is fine. If you're listening to jazz or acoustic music through full-range speakers, you'll probably notice the car amp's limitations. Some enthusiasts pair car amps with digital signal processors, DSP units that add EK and crossover control, but now you're adding another $100 to $300 and more complexity. At that point, you could have just bought a decent home amplifier and been done. The alternatives you should consider. Before you commit to the car amp route, consider what else is out there. Entry-level home amplifiers and receivers have gotten incredibly affordable. A Yamaha or Denon refurbished receiver with similar power output to that car amp costs $300 to $400 and includes proper volume control, remote, multiple inputs, tone controls, and safety certifications. Yes, it's more money up front, but it's plug and play with zero headaches. For powering passive speakers, especially if you're not DIY inclined, this is the smarter move. You'll have a better experience, better sound, and no insurance concerns. If budget is truly tight, look at used home amplifiers on Craigslist or Facebook Marketplace. Older integrated amps from the 80s and 90s, brands like Yamaha, Pioneer, and Onkyo, are built like tanks and sound great. You can find them for $50 to $100, sometimes less. They'll drive 8-ohm home speakers perfectly, no impedance mismatches, no power supply rigging, just plug in and go. The only downside is size and weight. Those old amps are huge and heavy, but they work flawlessly for decades. That's hard to beat. Powered speakers are another option. They have built-in amplifiers designed for the drivers they're paired with. Studio monitors from brands like Jabil, Yamaha, and PreSonus start around $100 per speaker and deliver excellent sound quality with none of the complexity of separate amps and passive speakers. You plug them into your source and you're done. For desktop or small room listening, this is often the best solution. So, can you use a car amplifier at home? Absolutely. Should you? That depends entirely on your situation, your skills, and your expectations. If you're a tinkerer who enjoys learning through experimentation, if you already have a car amp and you want to repurpose it, if you're building a budget subwoofer, or if you're setting up sound in a non-critical listening space, go for it. Just go in with your eyes open. Understand the power supply requirements. Respect impedance matching. Wire everything safely with proper fusing. Accept the sound quality limitations. Be prepared for troubleshooting and know that you're taking on risk that doesn't exist with proper home equipment. If you want reliable, high-quality audio without the hassle, spend the extra money on a home amplifier or powered speakers. The peace of mind and better performance are worth it. The car amp approach is not a universal solution. It's a niche option for specific use cases, and the internet has oversold it by glossing over all the drawbacks I've laid out here. Don't let anyone tell you it's just as good as a home amp, because it's not. It's cheaper and it can work, but those are different things. If you made it this far, hit that like button and subscribe for more no-nonsense audio breakdowns. Drop a comment and tell me if you've tried running a car amp at home and how it went. Did you run into the problems I mentioned, or did you nail it on the first try? And if you're thinking about trying it, tell me your plan so I can steer you away from the most common mistakes. Now get out there, make informed decisions, and enjoy your audio projects.